Now we will relate that G, Gibbs free energy, to chemical reactions, pressure, and equilibrium. So since we can't directly measure delta G, we have to calculate it from other measurements. The more negative delta G, the farther to the right in equilibrium will go. Remember, negative delta G's are spontaneous. So here are different ways to calculate delta G. We have 6 of them. So the first one, I don't want a highlighter. All right, so the first one, delta G of the reaction equals the sum of products minus reactants. And remember, we do need the number of moles in there, just like we did before. This uses those tables of standard values. This is just like that delta H and delta S calculation that we had, using the same thing. Delta G of formation is 0 for elements in their standard state. Our second way is our ghost equation. You can have it with or without so you can have it standard or not. You can do a Hess's law summation, where we use the equations. And, we had to reverse some and multiply some. Now, here's a new one that we haven't seen yet. Delta G not at standard conditions equals delta G at standard conditions. So you might need to use the equation from A above to get that standard conditions using the chart to put into this. R is your universal gas constant, T, your temperature in Kelvin, and then Q is your reaction quotient. Remember from our equilibrium unit, where we have the products over reactants. It's a little more involved than that, but to simplify it there. But those were using initial concentrations. Okay. Now we have another one. Your standard delta G equals negative RT natural log of K. So K, equilibrium constant, because at equilibrium, delta G is 0. Okay, and so, we had the ghost equation, so this one is RATLink. We had QSMAT. We like to call these by words just to make them easier to say. And our sixth one. Your delta G at standard conditions equals negative NFE, where N is the number of moles of electrons transferred. So we're going to have to look at the half reactions. F.
Sorry, I'm having trouble understanding right now. Please try a little later.
Apparently my Alexa thought I called her. All right, so F is Faraday's constant, and E is standard voltage. That is electrochemistry. So looking at the voltage is electrochem. So we're going to do this much, much more in the next chapter than we're going to do it here. Now, the next set of notes will be example calculations on all of these, so make sure your calculator is charged.